Finding the domain of a function algebraically can be challenging, but there's really three main things that you want to look out for, and if you keep these in mind, it's going to make these problems a million times easier. In today's video, I'm going to show you exactly what those three things are, and I'm going to talk about how you can apply those to find the domain of a function that you're given. If that sounds good to you, be sure to stick around to the end of the video, and without further ado, let's go ahead and jump right into it. Really, there's three main things you want to look out for. So three things are going to come up most often, and you want to make sure that whatever function you're dealing with, these three things are avoided, basically. So the way I like to think of finding the domain of a function is start with the domain being all real numbers. Start with basically being able to plug in any number into your function that you have. What you want to, or the process you want to go through, is then going to be eliminating intervals from that. And whatever you're left with at the end is the domain of your function. So in other words, think about the whole number line, all real numbers, any x value can be plugged into your function. We want to think about what x values that we would plug into our function that would cause us to break the rules of math. In other words, well, not in other words, but basically the way to do that is to look for three main things. The first one is you can never divide by zero. No dividing by zero. This is true always, right? Not just looking for the domain of a function or functions in general. This is just true in math in general. You cannot divide by zero. It's not a thing that you can do. A lot of people think that if you divide, for example, like 7 divided by 0, that's 0. That's not true. You cannot divide by 0. 7 divided by 0 is nothing. It does not exist. It's not a thing that you get. Therefore, if you're thinking about the domain of a function, if there's any x value that causes you to divide by 0, or in other words, wherever the denominator or the bottom of a fraction in your function is 0, that number cannot be plugged into your function, which means it should be eliminated from the domain. It's not a part of the domain. Okay, another very common thing that comes up is taking the square root, or any even root for that matter, square root, fourth root, sixth root of a negative number. So no even roots. So in other words, or for example, I should say, if you're taking the square root of -8, that would not work. You're not going to be able to get a number out of that. I know that's why imaginary numbers were invented, but you don't want to consider something that's giving you an imaginary number as an output to be a part of the domain of a function. So you need to make sure you're getting real, actual outputs out of your function for whatever numbers you're plugging into your function. So if you're ever taking the even root of a negative number, the input that got you to that point should not be included in your domain. Okay. The third thing you're going to want to look at is no taking the log or natural log, any logarithm of a negative number or 0. So no logarithms of 0 or negative. So if you ever have a log or a natural log in your function, it has to be a positive number. So you can't take the log of 0. You can't take the log of -2 or any other negative number. These do not exist. So this does not equal anything. Simply gives you no output. So there's no point that you could plot on your graph of your function if you are putting some input into a function that gets you log of 0 or log of a negative. So these are the three things you want to look out for. As long as you're avoiding these three things, you should be safe to assume that the number that you're trying to put in works, basically. If you don't have any fractions in your function, or if you don't have any even roots in your function, or if you don't have any logarithms in your function, the domain is probably going to be all real numbers. So these three things are going to account for 99% of the things that are going to cause domain restrictions within a function that you typically run into in any sort of calculus or pre-calculus class. I don't ever like to say that it's going to account for 100%. There's definitely going to be other weird functions out there that, there might be some sort of input that's undefined. But if you make sure to avoid these three things in any pre-calc or calculus class, you're going to be able to kind of account for all the domain issues or chunks of a domain that you should remove from all real numbers. So once you figure out what inputs would cause one of these three things to happen, you just eliminate that from your domain. Whatever's left over should be your domain of the function. Now, like I said, this blueprint that we just went over should be applicable to basically any type of domain of a function problem that you're going to run into. But just talking about the general ideas isn't particularly helpful by itself. So go click on that video right there and I'll show you an example of how to actually apply these methods to a problem.